Today we are talking about secants and tangents of circles. Secants intersect the circle at 2 times, while its tangent intersects 1 time. So we want to see how this looks like when both are drawn in the circle. When secants and tangents intersect, the angle measure is half of our arc measure. So it tells me line M is tangent to the circle, and then either find the measure of the arc or the angle that is red. We can't see the colors, but this first one is looking for this angle 1 right here, and the second one is looking for this arc right there. Kind of like with our intersected arcs, this angle right here is going to be half of the 130, so I'm going to do 130 divided by 2, which gets us 65 degrees. And then I want to do this one. The 125 matches the angle, and I want to find the measure of the arc. So I'm going to take the 125 and multiply by 2 to turn it into the arc. Which gives us 250. So I have some more here. Let me highlight what I'm looking for. Oh, it tells me what I'm looking for. So number 1 wants me to find the measure of angle 1. I know the arc is 210. So I'm going to take the arc length and divide by 2. So if I go arc to angle, I divide by 2. This gives me 105. On number 2, it wants me to find RST, which is this arc. So I'm going from angle to arc. I multiply by 2. Which gets us 196. And then my last one, I want to find the measure of arc XY. So again, I'm going from angle to arc. That means I multiply by 2. Oops. So this gets us 160. So, I can have non-parallel lines intersecting a circle. There's 3 places where the lines can cross. They can cross on the circle, inside the circle, or outside the circle. So for these ones, I want to find my angle measures when the angle is outside of the circle. The way I do this is I'm going to take my big arc and subtract my small arc. and divide by 2. So if I look at these, my big arc would be this one right here, this one right here, and this one right here. And then my small arc is going to be the one closest to the angle. If the two lines are touching inside the circle, so that was what we do if it's outside. Inside, we add the two arcs and divide by 2. So in this picture, I would add the DC and the AB together and then divide by 2. So for this first one, the crossing point is inside the circle, so I want to add the two arcs together. I'm going to add the 130 and the 156, and then I divide by 2 to find the value of x. Which gets us 286 on the top. And then dividing by 2 gets us 143. So on B, the crossing point is on the outside. This is where I want to take the two arcs. So I'm going to take the big arc and subtract the little arc, and then divide by 2. So I'm going to do 178 minus the 76 and divide by 2. That gets us 102 divided by 2. Which is just 51. Okay, so on number 4, it wants me to find the value of the variable. What I first need to figure out is the measure of this angle right here. Because I know that this one is 102, I know that DB is a straight line, so I can subtract 102 from 180 to get this angle right here. Which gets me 78 degrees. And then this one's crossing inside the circle, so I should have y plus 95 divided by 2 equals the 78, because the inside angle is what it equals. And I'm solving for y here, so I want to multiply both sides by 2. So I have y plus 95 equals 2 times 78 is 156. And then I subtract 95 on both sides. Which gets us 61. Okay, number 5 is crossing on the outside, so I want to take my big arc and subtract my little arc. And it should equal, or divide that by 2, and it should equal 30. So I have a minus 44 divided by 2 should equal 30. So first step here is multiply both sides by 2. And then I get a minus 44 equals 60. And then I add 44 to both sides. I get that a is 104 degrees. Okay, and the last thing we have is the circumscribed angle theorem. A circumscribed angle is when the angle is connected by two tangents. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So if I'm looking for angle ADB, I would take 180 minus this measure right here. So for A, I'm going to take 180, and then I need to subtract the central angle, which is 135. And that gives us 45 degrees. Same thing when I know the angle out here. If I want, I need to first, oops, I should have been going to E. So I want to find the measure of EGF. Which is going to be 180 minus 30. This one will give me 150. But that's not what I was looking for. I was looking for the value of x. So x is an inscribed angle. Remember, our inscribed angles are half of my central angle. So I want to take 150 and divide by 2. Gives us 75 for the value of x. Okay. Number 6 is touching a central angle, so I can just do 180 minus 120. Which gets us 60. Number 7 is an inscribed angle, so I need to first find my central angle. So I want to find the measure of angle PRQ. which I'm going to do by taking 180 and subtracting the 50. Gives us 130. And then by the inscribed angles theorem, I'm going to take 130 and divide by 2, which gets us 65 here.